Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. Hello everyone again. My name is Ahmed Hamoud Al Musa. This video I will teach you inshallah. How to use this Excel sheet to solve the second kind of a question from the rectification binary batch distillation. So it is fault only the question or the problem with constant XD only, not for the or for the same of the previous kind, which is only for the constant reflex ratio. So let's go through it. This Excel sheet is originally developed by Dr. Sabri, Jazallah khair. I will ask him for upload this two Excel sheet for you on the blackboard. I hope it help you on your assignments and homeworks, or to be sure in the when you solve some question. So let's begin. First of all, the doctor gives us the Excel sheet as what you see here, with the number, because it is it's for this the last problem in the Dr. Sabri slide for separation, chapter 13. Like what you see here, they say 100 kilomole mixture of 14% A and 16% B is subjected to batch distillation column at 1 atmosphere total pressure. The column has three trays, still pot, and a total condenser. The top product contains 96% of A. The final concentration is of residual is 4% A. The reflex is a saturated liquid, and V is 10 kilomole per hour. Like what we see here, it's give us the W naught. Let's give us the W naught and XW naught. Also, it's give us the number of the stage, which is he give us three trays and still pot. So we must add the three trays and the still pot to we will have the stages 4. After that, he give us the XD, which is the top product here, which is XD equal 0.96. XW also, which is 0.04, and also it's give us the V, which is 10 kilomole per hour, and it is constant. They ask you to calculate amount of top and bottom product. He want from you to calculate here D total, which is top product, and the W. The second question is state that what is the initial and final reflex ratio should be used. He want from you RI and R final. And the third one is the operating time. He want from you to find the time of operating. So let's go through it one by one, or step by step. First of all, it's easy to the first question is material balance, so it's easy to solve it. Like what the doctor put here in the slide. This is the given from the material balance, which is W naught equal T plus W. This is equation 1, and the component material balance, which is will be like this. Then solve the two equations simultaneously or from the calculator, and you will get the value of T and W, which is 39.13 kilomole, and the W is 60.87 kilomole. After that, you can go to the second question, which is to find the initial and the final reflex ratio. By default, all of you should know the where it will be the initial reflex and the final reflex. What is must be to get it for initial R. You must for initial R you must as written in slide on doctor slide, you must get the you must like what's written here for the R initial, which is R minimum, which is this is LV initial. How to get R initial? It's through the so as we know, R initial. R initial at point when XW equal XW naught, which is in this case is 0.4 as stay on the question, and R final at when XW equal XW, the final one, which is in this question 0.04, the residual material. So let's go to the Excel sheet now. As you see here, the doctor predict the value of alpha, or the relative volatility, which is here, from solver by a technique. I will leave this now. I will teach you other technique, which is not easier, but maybe more. It will give you more. It will give you for all the type of question answer, because the alpha, it is some of the question, the equilibrium line, this line, it's like this shape. It's like this. If you this y, for example, and this x, and this q line, it's like this shape. Let me change the color, for example. It's like this. It's not like this. I'm sorry. It's like this. Not like this also. I'm sorry for this drawing, bad drawing, like this. Okay, so it's like not give you it's go to the this side uh, very much. So this will not give you uh, from the doctor technique, which is using solver from Excel, not will not give you relative value, because some point here will not go through this line. This point here, it is error, so it is not preferred to do it with this shape. So inshallah, I will after finishing this example, I will go quickly through my technique. I discover it, and I hope it help you. So let's now stick to what is here from the lecture, and for example, let's say this is it is given from the question. Uh, some question, it's like give you the only the value. So the doctor, what I will go through the doctor way very quickly. It will give you only the point. So what you do, the doctor go here and make this column, then not column, sorry, the this the I forget what they say about this thing. No, not important, not important. Then he put the equation, this equation, if you remember this equation, and he put here any number he wanted, any number, like let's say for example 6 or no, let's choose for example 4 for example. No, when, oh, not here, I'm sorry. Let's choose here 4. It's predicted variable value. So what he do, the doctor, he go here and put assumption here, initial assumption for trial and error. Then from this from this equation, it will calculate the y predict. He want this y predict by changing the value of alpha, or relative volatility, to become as this value. So like what you see here, all the values for y predicted is connect with the x value and alpha. Why he want the alpha? Because he wanted on because the chart to draw this line and the operating line, etc. If you see this, the code of this point is connect to the alpha. So if we go here and go to the data, to the solver, maybe some of you not have the solver, it's no problem, it's easy. Go to the file, to add on, then to the option. Yeah, it will this site will display for you. Then go to the data, not data, add-ins. Go to the add-ins. After that, when you go to add-ins, you will see the solver this solver add-in here in this place. Go to it and click on it, then select go. It will go here, which is active, from the inactive side to the active side. Then press OK, and that's I am already activated it, so no need to also activate it again. Then when you go to the solver, set the objective. Set the objective. The objective is this. Which then put value of it's like equal of equal this. Oh, it's not. Go here, which is this. Actually, this before solver. Let me make you know what this. This actually it is the sum of error. The sum of error. You want the error to be minimized. The zero. Here 0. So what you do? Go here. Go to the solver. Then choose this point or this column. Then you want it to be value of 0 by changing the variable cell, which is alpha. You want changing alpha to get y predicted equal y, and that will make error 0 or go to 0. Then add here on the constraint, add that this y predict equal this y. Okay, it will be added here. Then press solve, and it will take some time to solve it. Also go again and it's not giving us the true value again. Let us again repeat this by set this objective value of 0 or minimize it. You want it to be minimized, not like minimize the error or the total of error. Then by changing the alpha value, which is this, and the constraint, you must y predicted equal the y value. Solve. Yeah. Solving. There are some problem here. I don't know why, but like what I see, it's hard for the solver to find this number. Let me check it. Hello everyone. I know now the problem. You must put the initial guess. It must be like near to the right answer. So it's if you put it 6 here now, it's before that it was 5.73, and when I make the same the same step that I teach you it in this video, it gives me 6, which is mostly near to 6.0339. But now let's take the 6's as initial guess and make the solver again. Set objective, which this value of 0, by changing the relative ratio value, and this is constraint that y predicted value equal the y. I want the y predicted value to this is like condition. They must be okay to to this is the difference between the solver in the Excel and the goal seek that I will teach you on it after a moment, inshallah. Then this oh uh, let's choose 5.9 for example. After that, go to the solver again. I don't know why the solver is make this. I think yeah, okay, all the things okay. Solve. I hope it's working now. Okay, let's say it's 6. It's okay 6. Uh, we know it's 6.3, which is not this big difference. If you see on the column here, it's the same, almost the same. When it's 6.0339, it's almost the same also. So and it is minimum the total of error than the previous one. So let's make it like this. After that, from the question or the last problem in the lecture slide for chapter 13, the n, the number of stages for the xd, it was 0.95. This you must put here the value. You must put because here the code, it will use this value and this value, also this value and this value. So make sure you put the value that's in yellow, so that all this thing will appear for you. As we say, the question is say that xd it was 0.9, oh sorry, 0.96, and the v equal 10, w not equal 100, and xw not equal 0.4. For as we say, for initial condition, we must have the r have the xw, which is this, to equal 0.4, which is xw naught. So go here to this point, then to the data, also to the what if analysis, goal seek. It is easier than solver, but it can't solve this because it's need some condition to control the solving of the solver. Then go to choose the value you want to find it. This is what the goal you want it to be 0.4. By changing what? By changing the R initial, or the initial reflex ratio. Then press OK. It will give you a good value, which is 0.4, which is the same as we want, and the R initial will be 0.492. Then from this, the slope will calculate spontaneously from the Excel sheet itself, because the code it is like this. It will take the r over r plus 1 and will calculate it spontaneously. And also the intercept by itself, it will take the value of xd minus slope multiplied by xd also. After that, like what you see here, you can see that we first of all, if you remember from the previous video, why there is 9 point here, because it is 4 stage, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 point. If you want only 3 stage, you want only 7 point, which is 1. It will here 1, 2, 3, 4, 5, 6, 7. So you will what you will do, you will delete 8 and 9 and put on the last y value 0, so it will become, so across the x-axis. It's like the y equals 0, so it's like it will make intercept but on the x-axis. And if you want to add more stages, like what we see, say in the previous video, you must from this not this one, Control C, copy the code and put it here. Then in the next one, make it equal to the previous value, which is here. So the 11 point equal the 10 point, but the 10 point is you copy the 8 code. Also here the same way, but make sure that the every last y is equal to 0. Like for example, for this I make it for only for the to see it only, not like this. See that always the last one 0. Then this point also the same as x. Copy the code of this, then paste it on here. It will paste also the code, and it will take the same value here, but be sure the code is correct. It's like you want it to be same like this. Take the same value, but this is the shifted value, so it will not be changed. Make sure that this value it's always like this. There are dollar in before the A, before the letters and the numbers, so that it will become always constant. It will not take something else, like it will not like this. It will take the down one, down it will always take this number. So let's go to this. After that, let's get the R final, which is you must find it 0.04. The same way, go to the what if analysis, goal seek. You want this cell, choose it, then to value 0.04. By changing what this R final, the final reflex ratio. Press OK. It will give you predicted value. It's bad. Like what you see here, to uh, give you this point or this number for final reflex ratio. Then on the same way it will calculate the slope and the intercept. This also will be manually or by default from the Excel sheet. Also it will make it. This always 0. This is the same as this. It's like this is the beauty of Excel sheet. I hope it help you in your study. After that, you will take the R initial here and put its value here and the final here. So and between them try to find for point. I'm sorry, for point. So for example, if we take this point in consideration, you want xw to be 0.22, like what we do in previous what if analysis from data section. Then goal seek, then choose the cell to value what 0.22, 0.222. Then by changing the reflex ratio. Click OK. It will give you some closer value, which is okay. And this the reflex ratio as we see here, and the slope you will put it here. Then when you finish this point, when you fill this table, you will find by default and spontaneously the Excel sheet, it will calculate this for you, which is y value. This y value. This is for integration, and like what you see here, from this code that you see, also this, it will calculate it for you. So you don't need to put here anything. This is will be ready for you to take it. Then the integration, the Dr. Jazallah here make it for you by numerical approach, but you must fill this 6 points. Then it will also calculate for you the time from the equation, and this integration is this. The equation of it is this. Maybe some of you not know what is this. It is from this equation. If you remember, T equal W naught X D minus XW naught over V integral XW to XW naught dxw over 1 minus L over V multiplied by XD minus XW squared. So what is the Y value, which is here? This is the Y value, which is 1 over which is this thing. I will choose another color. This is the other value, the Y value, the function value, 1 over 1 minus L over V multiplied by XD minus XW squared. This is the Y value. They will calculate this for you for every slope and XD and XW points. As we see here, oh, excuse me, XD it's already constant. It will take it from the up side. like what you see here in the code. See that? So for see the formula, it's take the xd value. It's constant. It's not changing. The only one change is xw and the slope, which is L over V. Then from that, from the numerical integration formula that the doctor, to make it easy for you and put it, it will calculate the integration. After that, it will calculate the time from the same of this equation. Only it will put the value of integration instead of this whole thing. Instead of all this term, put the value of integration that the doctor make it easy for you and put a formula for you, and only put the number for this variable, which is already on the question. This is 100, this is 0.96, I think, this is 0.4, and this is 10, and calculate the t, which is like also the Excel sheet provide for us the answer 10.95. And now let's take the now we finished how to deal with the Excel sheet, the two of Excel sheet. I hope I helped you on this clarification, and I think I thank Doctor for let me sharing this knowledge what that I know learning it from him, and thanks for him for this amazing sheet. Now I will teach you the technique I find it easier than the solver and this thing, which is, let me find some example to solve about it. Hello everyone, I found the question, which also it's like the same. If you remember what I say, it's like this. It's like this shape. It will not give you a good relative volatility when you use solver. So you must use this technique, or other than it, you must use your hand. So before or let we read the question together. The question say that 75 kilomole liquid feed containing a mixture of 50 mole percent of normal hexane in a heavy hydrocarbon compound is subjected to a multi-stage batch distillation of 3 stages, including boiler, which is still both. At a total pressure of 1 atmosphere, a liquid distillate of 90 mole percent of normal hexane is required to be maintained by continuously adjusting the reflux ratio. Assume that 53% of liquid feed is vaporized as a distillate. I'm sorry. Determine the time required for this distillation process. The reflux is a saturated liquid with boil-up rate of 8 kilomole per hour, and the equilibrium data is given in this table with the mole percentage. Be sure it's in mole fraction, not on mass fraction. Otherwise, you must convert it to mole fraction. So, first of all, let's take this only the equilibrium value. this is only the what we concern now. The other is the same as the what we do in the previous question. So questions and the same step. So this is the line. If you see it, just the red one, not the red one. I'm sorry, blue one. You will know what is the red one after that. But first of all, let me disable the red one so that you will not confuse. Chart design, select data, predicted. Let us hide it. Okay, now it's okay. Okay, this is the equilibrium line. If you see it, this is the equilibrium value, equilibrium line. Sorry. If I put the let me put the equilibrium or the Q line so that you know the shape. What I mean the shape I mean. It's the same value. Until one. So let's go here and make not chart design. Select data. Add another. Let me say call Q line. Q line. The X value. The same. No matter if you choose the left or the right values. So, like what we see, what you see here, see the equilibrium line. It's not not shape like this shape, you know. It's not that like this shape, uh, not like this. Not that. It's like have some. Okay, not like this, but it's like, you know. I hope you know what I mean. So let's begin how to find it. So what we must do, if you remember from this Excel sheet, the x value, uh, the x value, which is this, it's used alpha for what? For calculate and the previous y value to calculate the x value. It's like a function to it's like make a x function of y by rearranging this equation to give you a number here. So we make the same. So we want a function of y, x equal a function of y. How we do that? We want what? We want a function of y. How we do that? We want x equal function of y. So this also the Excel will make it for us. The Excel actually make everything easy for us. So you must take the all benefit from him. So let's begin and in this way, or the way I found it. So first of all, you must like what I am doing here. After that, you put the value from the question. You make this line, which is the inverse of this graph or the chart by inverse the x and y axis or x and y values. So you put the y value, you put the y value and x value. You put the y value on the x-axis and the x value on the y-axis. So it will give you this chart like what you see here. So I don't know why it's not. Start with chart design, select data. Actually, I don't want this equation to go, so let's make put it here. Okay, no problem. Keep it like this. So if we hide the trend line from there, you will find this. This is value from this the original one. That also we use it for draw this the equilibrium line. Like what I see, I reverse the value. So the y value in x-axis and the x-axis in y value. So that what from this what I will find. I find that the x it will be a function of y. That's what I want. So as we all know that the Excel it's have you can put a trend line which is give you the best fit line for the equation for the point, but this best fit line it's give you for the linear equation, so you must make it you choose other format for the equation that will make the trend line and the R more equal to 1. First of all, display equation and the R squared. Like what we see here, the R is 0.8347, which is very small. So what we will do, that we will choose polynomial. Then after that, add the order until you get for the polynomial equation a suitable R, or if you see the first of all, let me see delete the previous one. You will see this line of the fit line or the trend line from the Excel. You must see it at least like section this line. So we add also another order, also another one. Always choose polynomial for this shape. It is the best one for this shape, and like what we study in Numerical 316, the polynomial is always for linearization. Linearization is good. So we can also add more, but 5 it is enough. 5 it is enough. 5. So we can only, if you want to go up, you can. Now, like what we see, now the function of the trend line is shown here, but be like don't confuse. We reverse the x and y on this chart, so that he give us y equal f of x, but actually it is x equal f of y. So we will take it this value. I hope you are not confused with me. So we take this function and put it here for only for example in the x-axis because we x value because we need x uh, we need the function for x to give a suitable predict y. So when we put all this plug all this value all this equation in in this number we and the y value we copy it from here from the original question which is there, and the x value which is a function of y, so we put rather than x here the value of y on the excel, so it give us this numbers. So what you will if we plug or we draw this value as a chart in this chart like what you will see that it's sure it's the predicted one. So see it is almost the same line, it's in the same line. So when you use it for the excel maybe it will give you more accurate answer than the alpha, you know. So you go here to this excel sheet, and what you do, you put here you put this equation for x, you know, for x, and now you don't need to put alpha because be sure that it take the number of this for example if you want put the equation here, take the y value of this, not the same that this, take the previous one, no. Okay, and this will make a function for you, make the point for you, then repeat the circle again and find the for this question, okay. And that's it. I hope I helped you on this. I hope I helped you on this videos, and thank you for your listening. Before I leaving, I don't forget anything. Yeah. Mm. Yeah. Thank you for listening. You're listening, and I hope I helped you in your in this course. And I hope you all the best on this course. It is a good course and beautiful. I hope you take from it as much as you can from information, which is will help you for your life as a chemical engineering. And I hope you now you love the Excel. It is a good program for us and other major. And that's it. Thank you for your listening, and assalamu alaikum wa rahmatullahi wa barakatuh.